If autonomous flight's going to be a thing, you have to find a use case where it really, really matters.
Today's guest is Keenan Wyrobek, co-founder and CTO of Zipline, the world's largest autonomous drone delivery company. We'll explore how they went from a crazy idea of delivering life-saving medical supplies to remote villages in Africa to delivering products right to your doorstep using drone technology that's safe, quiet, and efficient. It's a lot. How do you approach something like that?
Every new phase of aviation is just way harder than people think. We started in Rwanda. It was just such a compelling use case. We started just with blood. The need was so acute. We visited these warehouses full of supplies that were expiring. The deeper we got into it, the more conviction we had that we could solve this problem. If you could hold it back in one place, deliver it when you know what blood type is needed where, just a game changer use case. We do that at scale in a bunch of countries around the world now. Just a huge amount of volume, and we're still scaling in that world.
Aviators, welcome to the Flight Club podcast. I'm your host, Jason Middleton. I'm a pilot, I'm an aviation entrepreneur, and I'm a huge fan of the people that make up our diverse aviation community. And now, Keenan Wyrobek. Keenan, welcome to the Flight Club podcast.
Really excited to be here.
All right. I really appreciate you coming on. I have been a massive fan of Zipline ever since I found out about it. I think what you guys are doing is really, really amazing and important and needed. So I'm super excited about this episode, but I'd love to hear a little bit about your background and kind of what got you into robotics. Were you like a kid that tinkered around?
Oh, definitely. I'm a kid who took everything apart that anybody would let me take apart.
Yeah.
Some things that I wasn't supposed to take apart. But yeah, I just always loved building things, taking things apart, building things, trying to solve a problem, trying to understand how it worked. That was my childhood.
Yeah. Where did you grow up?
I grew up over in Walnut Creek, so in the San Francisco Bay Area. Yeah. Got really excited about medical robotics. Went out to Johns Hopkins for school and loved that, but also got a bit disillusioned by that world.
Yeah.
And and then my education was all sort of between product design and robotics. And the things I tried to make fly when I was a kid weren't very successful.
Were you into model planes? Did you ever get into that world?
I was a little bit into model planes. I was just way more into things that were a bit crazier. Yeah. I remember somebody gave me two 049 engines, and I tried to make a little dual helicopter thing out of that. And
how'd that work out?
I didn't get badly injured, but good memories. Yeah.
We lost a dog that day.
Yeah, it didn't fly very well, but
oh, that's hilarious. Yeah, I loved model airplanes when I was a kid, and I never got into robotics. I think that was probably a little bit I'm a little bit older generation. It wasn't really a thing yet, but my son is super into STEM. My 13-year-old loves robotics. He's going to be blown away by this interview. When I told him where I was coming, he was just like, "You got to be kidding me. Can I go?" He wanted to come up. I'm like, "You got school, you got water polo tonight. Sorry." But STEM is a huge thing for him. And a lot of the young kids now, it's becoming a really cool thing. And we learned, my son, 13, I think he was maybe 11 at the time. He's like, "Dad, you got to check this out." He loves Mark Rober. And Mark Rober did an amazing shoot with you guys.
Yeah.
And that's how I learned about Zipline through my 11-year-old.
I've been asked for an autograph one time in my life.
Yeah.
A neighbor kid came knocking on my door, and he's like, "Can I have your autograph?" And I was like, "Why?"
Really?
He's like, "Yeah, you met Mark Rober."
Wait, just because you met Mark Rober,
Yes.
that warrants an autograph?
That's what elevated it to all the way there. But I'm really passionate about that. I spent about 8 years of my career working on an open source platform for robotics called ROS.
Yeah.
Started that in grad school and spent a long time on that. And
that software is pretty much in every robot.
Oh yeah,
today.
It's taken off like crazy.
Yeah.
Everybody does robotics uses that, and every academic lab, every research lab, lots of companies, and it's also just part of what's so exciting now is how accessible STEM and robotics is now.
Yeah.
You can get your hands on these open source platforms, and you can really, if you have an idea, you can bring it to life.
You can make it work. The more these kids, the more that the young generation gets involved in this stuff and gets excited about it and thinks it's cool. It's actually really cool to kind of be a tech nerd now and care about this kind of stuff. And there's so much stuff on YouTube now. And I think it's just such a great time for these kids to be growing up.
Absolutely. Yeah. If you would have told me robotics and STEM would be this hot when I was a student, or even things like when I go into grad school and stuff like that. It's like you're like, why on earth are you doing this? Like, you should do something that's going to have a career, and it turned out well.
Just wait, you'll see.
Yeah,
I'm visionary. Your first application for Zipline was basically flying critical missions in Africa, delivering blood, delivering critical medical supplies to remote villages. And did you guys see a need and develop an application for that, or did you have a vision? I want to do this, and then did you go seek out somebody that needed that for Zipline?
yeah.
Was it like was it chicken or the egg first, Keenan?
I was looking for next thing I wanted to focus on, and Amazon had just announced, drone delivery coming, next year, and my wife's an epidemiologist in public health, and she was like, talking about all these vaccine campaigns and other health interventions that just get stuck on logistics, right? They have the supplies, they have the doctors, they have all these pieces, but they don't, just literally getting the supplies from point A to point B was the problem. Yeah. That's what got us looking at it. And we spent a bunch of time in Central America and Africa, just going looking at it. I am personally a very skeptical person. So I was like, cool, we're going to go look at this. I'm going to come back with 1,000 reasons why we can't make a dent in this problem. But the deeper we got into it, the more conviction we had that we could solve this problem. And I'm not like a tech early adopter kind of person. I want my stuff to work. And when I've been studying aviation and new transportation technologies in general, but especially in aviation, one of the things that struck me about Amazon's, like, it'll be next year, was every new phase of aviation is just way harder than people think, right? And every new type of aircraft, every new sort of use case in aviation, unfortunately, often ends up in even fatalities during their development, things like that. So this was one of those things where it's like, hey, if autonomous flight's going to be a thing, you have to find a use case where it really, really matters. In order for the regulators to get on board, in order for the customers to be patient and the partners to be patient. And that's part of what got me excited about this. Plus the need was so acute. We visited these warehouses full of supplies that were expiring, and it just became really clear, like, hey, the supplies are there, the doctors are there, they know what they need.
They just couldn't get them to where they needed to go.
Exactly. And that's where we started in Rwanda, in Africa.
Rwanda, yeah. Sorry about that.
Yeah, and it was just such a compelling use case. We started just with blood, didn't do anything else, just delivering blood. Blood is one of those things that it's rare everywhere in the world, right? Mm-hmm. And it's more expensive than you think. We think of it as like a free thing as we donate it, but the cost of collecting it, testing it, typing it, transporting it, all of those things adds up to hundreds of dollars per unit of blood everywhere in the world, and there's never enough of it. Yeah. And so being able to, and the shelf life is short. It's short as 7 days for the time of donation to where it expires. And so if you can hold it back in one place and deliver it when you know what blood type is needed where, just a game changer use case. Yeah. And that's proven out big time. So we do that at scale in a bunch of countries around the world now. Just crossed 100 million miles flown, just a huge amount of volume. And we're still scaling in that world. Yeah. Delivering about every 60
It amazes
seconds.
me how much you guys have already done, and you haven't even made a dent in the market yet.
Teeny piece of the pie.
It is wild.
Yeah.
Let's talk about the technology for a while. This is your kind of wheelhouse. So is Zipline, do you consider it is it a robot? Do you consider this a robot, or is it what is it?
Yeah.
Because it's kind of hard to really, me as an aviator, is it an airplane? Is it a helicopter? Is it a drone? What is it? But it does so many things.
Obviously uses robotic technology. My favorite definition of a robot, it's a bit controversial in the world I come from in robotics, which is a robot's just a machine that doesn't work yet. Right. Once it works, you call it a Roomba, you call it a dishwasher, you call it a Waymo. If you live around here, you ride a Waymo now in a car. And that's kind of emblematic of these things where, the robot's sort of where those of us who love the robot technology geek out on it. But once you make it really useful, people think of it differently. They think of the use rather than the robot. It's everything, right? Like, it's a new form of flight. It's a new form of it's autonomy in the airspace. And so a lot of what Zipline is how do you deal with that huge breadth of both technologies and uncharted territory, and handle it really responsibly and in a way that's going to really work well. And that's something that it's a lot of where my energy goes. And getting to 100 million miles with if 100 million miles on the road, for example, you're talking about, depending where you are in the world, at least 2 fatalities. In that distance, we've had no injuries. You're talking about dozens of hospitalizations from, not necessarily fatal, but hospitalization level accidents. And so, yeah, just trying to piece all those technologies together, navigate the new world of autonomy and flight and this airspace, which is a challenging airspace, like low, near the ground, over mountains. You're not recommended to fly in those conditions and storms, right? And that's really how I think of Zipline. It's all those pieces of the puzzle, moving them forward every day in a responsible way.
Yeah. Well, I mean, like to your point about fatalities and hours flown. I mean, in normal aviation, it's about every 40,000 hours there's one fatal injury, and you guys have flown millions of hours now with nothing.
Yep.
I mean, that's that says a lot about the tech.
Part of what's powerful about it, and it's sort of the promise of autonomy, right, is every test flight we do, and we've done hundreds of thousands of test flights. Obviously every commercial flight you do, you're studying every single one for, you're not looking for like, did something, bad happen, which for us is like a parachute landing where it floats to the ground. We're looking for like, did it come anywhere close to coming to a parachute landing? Study that data, use that to improve the system and just keep improving the system, day in, day out. And now, we've been doing that for 10 years. And how good the system gets when you're able to just keep taking every little lesson, even these things that we call, that aren't really misses, we call them near misses. Take every one of those lessons into the system. The system gets really reliable and powerful over time.
Well, you mentioned the parachutes. I mean, even in general aviation now, there's Garmin Avionics. They've come up with some really handy tech for autonomous landings for airplanes now. And I was actually last week, and I was in Kansas City with some of the head people over at Garmin. And, they were talking about the parachute and then the auto land. And they said the parachute is, for like Cirrus aircraft, human carrying aircraft. Parachute is if something goes wrong with the airplane, use the parachute. If something goes wrong with the pilot, use the auto land.
Yeah.
So there's like, they're applying what you guys are doing into aviation circles now. And it's getting pretty good.
It's really exciting, right? Because it just makes it more accessible and safer.
The worst case scenario is that you don't want to do the parachute deployment.
Sure.
So do you guys, have you actually had a parachute deployment?
Yeah.
In testing?
In testing, we have lots of them. Philosophically, if we didn't have a lot of parachute deployments in testing, we're doing the testing wrong. Right. Like the point of the testing is to know where the limits of the system are and to know, right? Because if you don't know where the whole point is in testing is you know where the limits of the system are. Yeah. So when you operate it, you stay, away from those limits, if that makes sense, right?
Totally, yeah.
And so, you're always pushing the limits in test. And then obviously the other side of what we do, once we understand what caused a limit, right? What caused a paraland and some extreme winds or something, then we're studying, how can we actually make the system handle those winds to expand the limits over time. There's and in a lot of places where we fly in the world, when we're doing these medical logistics deliveries, right? We serve about 5,000 hospitals around the world now. About a third of those deliveries are emergencies. So this is, blood right now type situations. And in most of those countries, we have permission with the regulator to actually fly way outside of what we would call our limits. And now that might introduce a risk of a paraland, maybe 1 in 1,000 flights. But of course, you're saving a life, those other 999 flights. So you should do it. And so you will see paralands in those kind of situations. And even with those paralands, no one's gotten a scratch on them. And that, again, it's all layers of safety. So when we fly, we do every little thing we can so that if you had a paraland, we cross a road perpendicularly is a good example of that, right? So if you have a paraland, it'll be in some tree canopy, no big deal, right? As opposed to on a busy road, statistically speaking.
I kind of wrote a list of things. Like if I'm starting a company like this, what are my technical challenges? And there's a lot of them in this. I mean, you have noise, range, payload, safety, loading, unloading, obstacle clearance, traffic avoidance, weather, that's just to name a few. What were your biggest obstacles and how did you guys kind of navigate? I mean, out of all these things, it's a lot. How do you approach something like that? I know that's a super loaded question, Keenan. I apologize, but
no, it's a great question.
I'm just super curious about it.
There's a great quote that goes something along the lines of, we don't do these things because they are easy. We do them because we thought they would be easy. That's part of it. You got to be a bit naive. If you really knew how hard it would be, like if I really knew how hard this would be when we started, I don't know. Like I'll give you one example from the early days. When we started working with these governments, I was sure we'd be able to go buy someone's drone, modify it for payload delivery, and serve our first customer. And so went out to everybody who made drones that we thought could meet the use case. And the best deal we got back then was a drone, a $200,000 drone with a 200 flight warranty if I did not fly it in the rain. And to be clear, we fly in the rain pretty much every day in these countries near the equator. It just rains.
Yeah.
It's just part of it.
Yeah.
And so that was an example of a moment of like, oh shoot, like to serve our first customer, we gotta do something ourselves here. And a lot of things have been like that along the way, and some of it is about, so some of it has been painful surprises. But some of it has also been just a matter of being diligent and slowly working up the capabilities. And some of it is just finding those special people, right? Weather forecasting is a good example of that. We were pushing really hard in a lot of countries we're operating around the world to improve our system's ability to handle crazier and crazier weather. And but it was really clear that a microburst, the formation of a thunderhead, we were never going to handle it, and we had to be able to forecast it well and just fly around it or not fly through it. And we found this person who had been the key meteorologist behind Weather Underground, if you remember those folks.
I remember those guys, yeah.
He's like, look, let me at your data. Let's see what we can do. And he now is on the team and part of our 3-person forecasting team. But what he found was that our flying drones are some of the best weather stations, period, because they're better calibrated to measure wind and other things than anything else. They fly at very high densities around these countries. And so when we took that, historical data set of billions of data points and use that to build a weather model to forecast what we needed to forecast, it turns out we could build a better weather model for these microbursts than anybody else could.
Wow.
And it's been
so do the drones they have built and obviously have sensors, but I mean, you're measuring barometric pressure, like humidity, like what are you guys measuring?
They're measuring 3-dimensional wind, which is really powerful.
Yeah.
Because they're not on the ground, like most weather stations are on the ground. Their weather stations on the ground are affected by the buildings on the ground, right? So they don't, the vertical winds, like in the formation of a microburst, right? It's the massive updraft in the middle of the cloud and then the massive downdraft on the outside. We're measuring that 3D data. And so we have a quality of data that's just better than you can get on the ground because of that. And so, we measure everything you mentioned. We were able to use that and build a model against satellite imagery. And that's a good example of something we deployed. It's actually the first actual AI we ever deployed in our operations at scale. How many years ago now? 7 years ago, maybe 6 years ago. And it's been huge for us to have this really powerful weather forecast. We call it a near cast because we forecast out just sort of 5-10 minutes ahead of where we're headed to make sure we avoid those.
The implications with that are you could be saving lives outside of what you guys are doing eventually with that data. I mean, if have you ever experienced a microburst in person? Have you ever seen one?
In an airplane?
No, just being on the ground and seeing
one.
It is one of the most violent. I got to experience a microburst maybe about 7 years ago in Santa Barbara. It was the middle of summer. There was a bunch of lightning storms going on kind of north. And all of a sudden, we're at the beach. I'm at the beach with my kids. I have my 2 youngest kids. They're in the water boogie boarding. And I hear it sounded like a jet engine coming down the beach. And it's like umbrellas, surfboards, tourists, things are tumbling down the beach. And I grabbed kids out of the water. I put them up against the cliff and this thing hit us and it was so violent. And I've been in aviation for 30 years. I've learned a lot about microbursts and I've been told don't fly in microbursts and how to escape them if you're in an airplane, but I've never actually experienced it. And it was violent and you want to avoid it at all costs in aviation.
Absolutely. Yeah. And we fly the equivalent of 6-7 times the equator to the earth every day in our operations right now. And in a lot of those, we're encountering these kinds of conditions on a regular basis.
Yeah, when you're in tropical environments, they're all around there. 5 degrees north, 5 degrees south is the worst weather in the world.
Exactly.
I wanted to ask you about icing.
Yeah.
How are you guys dealing with icing in these things?
Yeah, no, great question. So similar challenge, right? What can you forecast versus what can you handle, and making sure you don't have an overlap between what you can't forecast and
Right.
what you can't handle. Yeah, we've been doing a lot of testing with icing. One of our test sites is out in Wyoming, so we can learn a lot about it. And there again, everything's a layered approach for Zipline, right? And so a good example of that is we're very in the worst case of icing, you're just going to get buildup. In the worst, because one of the things that I didn't appreciate is icing. There's many different variants of icing conditions, right? Different types of buildup, different types of conditions, and they'll build up ice very, very
Collection
differently.
rates, yeah.
Yeah, and so if you think you've nailed it for one of those, you haven't nailed it for all of them. And so one of the things that we as like again a backup to the backup is if you're in flight and you're building up ice on your rotors, we want to make sure we detect that very quickly, and we execute what we call a hover down maneuver, where we hover down, and we do that faster than the worst case rate of ice buildup you can have, so that
Okay.
you'll still end up with a very controlled put down of that aircraft. Again, in the worst case,
Yeah.
in most conditions, we wanted to detect it and then fly back to a dock,
Turn around. Yeah.
and wait it out.
Yeah.
And then, of course, for the very long term, we're starting to look at technologies and solutions that will enable us to shed ice. And there's a lot of cool things in the world, nanotechnology coming and things like that,
Coatings and kind of stuff
and
like
stuff
that. Yeah.
that I think will enable us to fly in more and more of those conditions.
Yeah.
Yeah.
Because your rotors, they spin relatively slow, right?
Yeah,
Which is kind of susceptible to higher icing
sure.
accumulation.
Sure. But even, yeah, we've done some testing with high rate rotors to see how much that helps.
Yeah.
I've been surprised that like the every solution I can find, the scale is down. Obviously there's solutions that very large aircraft use that we can't scale down here,
Yeah.
like piping your engine exhaust into your leading edge and things like that. But the things that scale down, I haven't seen anything that solves every icing condition that's
Yeah.
out there. And this is one of the reasons we've been just spending the last couple winters really getting deep into this. We have a few folks in the team who are really passionate about this,
Yeah.
and have developed even just like at our test site on Wyoming, different types of nozzles in different conditions where they're like, they're like that test site doesn't run 24/7, but they're like, up in the middle of the night, 3 a.m, like these conditions are perfect. We have never seen these conditions before.
Oh, really?
Break out these nozzles and let's fly it. And they shoot the nozzles up at the aircraft, fly through it and see. And then they put all these cameras on the aircraft to like really see exactly how the buildup is forming.
Yeah.
Land that aircraft down, 3D scan it, see exactly what happened to the buildup, if there
Mhm.
was any.
Because you guys, yeah, I mean, if you're flying in the
Yeah.
forward fixed mode, then
Yeah.
you could potentially accumulate ice on the
Yep.
leading edges of the foils and the wings and
Yep.
all that. But it's really the rotors that's a big thing, because you can always hover
Yep.
them, right?
Exactly. Yeah. So we want to make sure the rotors stay clear. And we've even experimented with how we stow the rotors in forward flight, the 4 rotors that get
Mhm.
turned off, how they get stowed relative to the sort of alpha and beta angles of the aircraft and to the
Yeah.
airflow, to minimize the accumulation. There's all kinds of interesting details you can do to basically get more and more, basically, we call it survivability of these extreme conditions.
Yeah. You talk about testing so much, and
Yeah.
your approach to kind of slowly, methodically solving problems, making it better, analyzing your testing. When I learned about the level of testing and flight, kind of flight testing you're doing, and you guys have far, far exceeded any aviation business by probably 100x,
Yeah.
I'm guessing,
Yeah.
in terms of flight testing. I mean, to certify an aircraft, they need a few hundred hours of flying it.
Yeah.
You guys have millions of hours.
Yeah.
Tell me about like the testing and like I guess the why. Like why
Yeah.
why is it because you need to prove the government? Like is there other factors besides you guys just wanting to make something really cool?
It's the unknowns, right? So if you take helicopters, right? The very first helicopters ever invented didn't get thousands of hours of testing. But by now, the heritage, the knowledge has been built up over decades of like every way a helicopter can fail, how a helicopter will behave, and the diversity of the environmental weather, wind conditions, things like that. That's all been built up over a lot of time, right? And autonomy in the airspace, flying these autonomously, let alone the vertical takeoff and landing capabilities, right? Like we have, a lot of people are working on vertical takeoff and landing electric aircraft, but none of them are flying in the kind of winds we fly in, the kind of weather we fly in, that kind of thing. And so the way we think about this is like we have to go through that journey that like the first fixed wing flyers, right, 110 years ago, a little bit longer ago now, right? Like those things didn't become anywhere near like the level of safety we think of, for decades after that, right? And so when we think about this and actually serving people at scale, it's just been very motivating to us. Like, hey, if we want to serve our customers, serve these health use cases, serve these delivery use cases, we have to maintain a safety record, which means we have to discover those issues in environments where we can learn from them and iterate quickly. We can't just be like, oh, what to say it in a more negative way. What scares us is a company who's like, okay, we're just going to go do this without this testing, and then bad things happen, in communities, and then that those companies will probably go away, but it'll hurt the whole industry. It could hurt people. We don't like, and that these are things we just want. We've developed an approach to testing in flight test, in ground testing, that has enabled us to really get past those things in those testing campaigns. And so, yeah, like this new aircraft that we're now flying, the delivery experience you saw, we've done hundreds of thousands of test flight deliveries at this test site, at other high volume test sites, at that Wyoming site in the snow. And to be clear, we have flown in the snow and in these icing conditions there, but we do not do that in commercial yet, because we've restricted the sort of operating domain is the term we would use, the basically what conditions we'll fly in, way tighter than we're doing in testing, until we get a lot more testing experience that gives us statistical confidence. I think that's one of the things that's kind of wild about when you think about these problems. It's safety is all about statistics, and if you don't have enough data, you don't understand your statistics, so you can't walk up to a community or a regulator and say this is how safe it is, and that's what we got to be able to do.
I mean, and I think that with the level of data and testing you guys are doing, I want to learn more about kind of what you guys are doing here, how it apply. Also, I think what you guys are doing, you're setting an example for what the future of at least short range air mobility for humans is going to be, what it's going to look like.
Yeah.
And it's funny, I asked this question a lot to guests. I had Ben Marcus on, which I know you're friends with. I always ask the question, like, when are we going to see pilotless aircraft with carrying humans? And what you guys are doing here, you're doing it very safely and confidently and consistently right now.
Yeah.
And the question is always comes up, would you get in an aircraft without a pilot?
I know I will.
It's more of a rhetorical question.
I know I will. I'm not quite sure when.
Yeah.
But I know I will. Like, I think there's nothing about the journey we're on that tells me you can't get to that level of reliability and safety that I'd be comfortable getting in it and putting my kids in it. It's going to take time. I think there's part of how we see the responsibility we have doing autonomous vertical takeoff and landing at scale first, right? Before people try to put aircraft in these systems, put humans in these aircraft, is like we're sort of plowing that way. And, we're in the hundreds of millions of flight hours now. We'll be the first to billions of flight hours. And we know you need that kind of data and experience to know what the requirements really are to put a person in.
You guys are pioneering this new world.
Yeah.
It's super exciting to me. And I'm a pilot. I'm the last person in the world that, we shouldn't have pilots anymore. I love flying. It's my passion, my career. But the question always comes up, what's the safest way to move the flying public?
Yeah.
And you have to look at the pilots. You got to start looking at pilots and where's the data, right? When you look at aviation accidents, overwhelming majority of aviation accidents are either direct cause of or a contributing factor of pilot error.
Yeah.
And when you develop systems like Zipline is developed, you eliminate so many human factors.
I got to spend a lot of time with pilots doing what we do at Zipline. And I think one of the things that kind of blows my mind about the expectation of a pilot is this expectation that you can spend, months and years of your life in a cockpit, with things going normally, and then in a fraction of a second, be able to, figure out what to do when things don't go normally, which is just a very hard thing to do physically for a human being.
Yeah. Just the adrenaline alone. Yeah. So you start, human factors, this kind of stuff comes into play. If there's an emergency, I need to deal with this. I've been flying for 10 years. Nothing ever has happened. Now I'm dealing with an emergency. So the adrenaline kicks up, tunnel vision goes in, you lose situational awareness.
Yeah.
And you have to make decisions.
Yeah.
We do get in simulators every 6 months and practice all this stuff, but there's
Yeah.
nothing when you're in the heat of the battle.
Sure.
It's different.
And this is where, yeah, I'm excited about autonomy. You mentioned the use case of the auto land, right? That's like, it's just so powerful to have that layer, right? It's just
Yeah.
another layer of safety, and then of course there's so many use cases for flight in the future, where that at least I dream about, when you can when you can commute in a quiet aircraft and like hop over all the traffic, and it's just easy to do that. But yeah, the systems have to be phenomenally reliable for that, and and obviously what autonomy unlocks is that like accessibility, where so many people can't access it.
The AI side of this too, when you have, I was interviewing John Cox, who's an NBC correspondent, aviation safety guy.
Yeah.
He was head of ALPA. He's on Why Airplanes Crash. Great dude. But I asked him about this autonomous passenger carrying aircraft, and he brought up Miracle on the Hudson. Was the first thing he brought up.
Yeah.
He's like, could a robot have done what Sully did in that? I'm like, well, if it was programmed, probably.
Yeah.
And it probably could have made the decision a lot quicker, and it probably could have made this. It probably could have done it better than the human did, if it's programmed to do it. And the AI tells it to do, hey, we can't make it back to an airport. What's next? Is there an open field? No. What's next? Is there a waterway? Yes. Okay. Which waterway? Let's do that.
Yeah.
And it can do it like that.
Yeah. It was fascinating studying that incident, because of even how many other pilots, sort of like didn't think it was possible. Right.
Yeah.
And like, that's part of what's wild about AI is you can take this collection of knowledge, you can test and test and test on simulators, things like this. You can bring it all into one system. And you can load in sort of more knowledge than a human can load in their brain and more. And like you said, the human factors sort of go away too. It's just there at the ready, no matter what. Yeah. And then you can also layer in, the superhuman things, right? I think this is one of the things today, that when I don't come from aviation. And when I started with Zipline, I didn't have an appreciation for, if you're a GA pilot in a small plane, like how much you can see and not see when you look out the window, right? Your field of view is not great, right? And the superhuman ability to see in every direction all the time, right? And sense in every direction all the time. Sensors like that can augment and just make things even more sort of more layers and more. You can tell how I think. I always think layers and layers of systems
Sure,
that give
yeah.
you more safety and
You're a
redundancy.
scientist. Yeah.
And it's just like, that's how we lay everything we're building. It's like, okay, how many layers do we have? Do we understand those layers well? And do those layers add up to a level of safety that we're going to be able to stand behind?
When you put all that together in a technology package, you can do, like, we're standing out here in your kind of testing facility, and you demoed some deliveries and for me, and it's foggy. You can barely see 100 feet out here, and the main Zipline drone was hovering. You couldn't even see it.
Yeah.
And then it delivers a package so precisely, and you can't, like, you would never even think of flying an airplane in that weather.
Yeah.
You could not even come close to landing. Couldn't fly a helicopter. It would be the most dangerous thing you could possibly do. Yet a Zipline is delivering something so precise. In fact, I kind of stood in its way for one of the demos, and it came down and saw me, and it moved over and landed next to me.
Yep.
That's just, when you think about the future of aviation, you have to look at that stuff, and you have to trust it in a lot of ways.
Yeah. And I think that the trust has to be earned, right? I think that's our philosophy. It's like, you have to, and the earning, it takes time, it takes testing, it takes the right team with the right mindset. It's easy to hire folks who, they want to just like write the requirements down, engineer the requirements, and ship it. It's like, well, hold on a second. Like, you get those requirements wrong. No one's ever done this before. How do you know the requirements are right? You got to go do a lot of testing, and you got to like be really open-minded. That testing is going to tell you your requirements were wrong. And like, at times you're going to have to go back to the drawing board and be like, no, that aircraft, that subsystem, that sensor, whatever it is, it's just, it's not up for the problem now that we understand the problem better.
You guys are currently operating in Dallas and in Fayetteville, right?
Today we're outside. We're in Pea Ridge, Arkansas today, here in the
okay.
U.S. And in Dallas, and then a handful of other countries all around the world.
Okay. Yeah. And those areas that you guys are operating, the vehicles you're using now, you guys, you're testing things and you're changing things. Like, it's so rapid watching you guys out here in your demo center, or your testing center. if something changes here, how fast can you change it on the, is it mostly
Yeah, no,
software
good
type
question.
updates?
Yeah, by the way, that wasn't a demo you saw out there. That was code that was written yesterday, and we go through millions of flights in simulation, and millions of flights on what we call hardware in loop simulation, which is a really if you guys aren't visiting one of our other facilities, but we have a room where you walk in and it's like you like the Matrix movie.
Yeah.
You see all the humans like plugged in. Same
You
idea.
haven't plugged in their brains.
Yeah, we
like
take the robot brains and we literally plug them in the hardware, and they think they're flying out in the real world. They don't know
Really?
the difference,
Oh,
but
wow.
we're able to just do testing and times on top of testing for that software. So our journey, we go depends what the change is, right? So hardware changes, are measured in many months, right? It can take a year plus to get a hardware change all the way through our testing. Software can take months, calendar months, but again, millions of tests in simulation before we'll then test it in our test sites to go make sure everything's looking up ready for it. But that a lot of what we don't talk about a lot at Zipline, but I think is a lot of the value we've created as a company is those test systems, how to use them, how to think about them. If you're doing a new feature, which layers of tests should you use, and how should you use them to get really, really good coverage of the new thing you're doing. And then we're constantly studying that stack of tests. Like every time, the way we think about it is if we discover something at a test site, that's an escape. It's like, all right, why did we discover the test site? We should have discovered that in a hardware in loop test, or that's that matrix style thing, or in a software in loop test in simulation, or we have dozens of ground-based systems upstream of that. And so anytime something is discovered kind of late in that chain, it's like, all right, we got to go improve that layer, improve that layer, improve that layer. It's literally a meeting every Friday. We call it test escapes, and it's studying every time it got discovered towards the last step. We then sort of improve the previous steps and just keep doing that. And we've been doing that for years. And I think it blows people away. I would estimate half of all the engineering we've ever done is just the test systems. It's not the actual system we're building. It's just improving those test systems over time.
I mean, you guys are kind of writing the book on how to do this. Do you envision, I mean, you're obviously a thought leader in this space, and what you guys have developed here is so valuable to the world. Are you working with any other organizations, and what's the big vision for you guys and within Zipline, and then maybe even outside of Zipline?
Yeah, there's a lot of things we're working on in that vein. There's a couple examples. We started with a thing a few years ago with the FAA called the Partnership for Safety, which this started when they visited us maybe 6 years ago now. And they presented what they were thinking of as a basically a standard for a level of testing required. And we actually stayed up that whole night because the testing standard they presented was lower than the testing standard we had launched with in Rwanda 3-4 years prior, and was way lower than where we were at the time. And of course, we've gone even to a much higher standard now. And really what that Partnership for Safety has enabled with the FAA, and we do this with regulators around the world, is just a radical level of transparency. We're just showing them everything.
Awesome.
Every issue we've ever seen in test, all of those things, because because this experience has to inform their thinking. Because we know it's informed our thinking, right? Like we wouldn't be where we are today without that experience, right? There's just no way. And so we do a lot of things like that. There's other things we're working on that are way more tactical, right? So a good example of that is transponders. So, ADS-B, we listen to ADS-B transponding signals from other aircraft, but the FAA doesn't want drones to transmit them. And we've been developing a radio technology that we use internally for our aircraft to deconflict with each other, that we would like to make open to other aircraft, other drones, and eventually other aircraft. So, and ADS-B is based on sort of 60-year-old radio technology. This is very modern radio technology that can scale a lot. And hopefully we believe that will be needed to enable the density of autonomous flight in 5 years, 10 years. And so these are things we're developing that we want to make open to the industry. That of course, by using them internally, it lets us harden those things and really soak them and iterate on them. So by the time the greater industry needs it, we can be like, hey, this has been proven. This is not a theoretical thing. Like, here's all the data we have.
No, I'm really glad you brought that up. I mean, I wanted to get into the regulatory stuff, but ATC systems right now are primarily using ADS-B and send and receive. But there's all kinds of things like when you have Zipline at scale, and there's thousands and thousands and thousands more aircraft in the air, right? Use
Yeah.
LA for an example. So is that, so you guys are not transmitting ADS-B, but do you want ATC to be aware of those, where they are?
Yeah.
Or, because I'm sure you guys are programmed, that the drones are programmed, the Zipline's programmed to not interfere with airspace.
So the way that's going now is with a system called UTM, which is an acronym inside of an acronym. So bear with me, but it's UAS traffic management. So unmanned aerial system traffic management is it's a bit of a jargony acronym, but as it's been we've now have a first version of this operating in Dallas
Okay.
between drone operators where we have some overlapping operations.
Did you guys develop that?
We were the first ever to launch it with FAA approval out in Utah.
Wasn't that some of the
Um,
work AirMap was doing? When
A
Marcus
bunch of
first
folks
opened
have
it?
been involved in this standard.
Okay.
It's been a standards development going on for a long time.
Okay.
And so, there have been a number of startup companies that have been participated in this. AirMap was one of those in the standards development. And the way I think about it is it's basically an automatic way to share route intents with other operators and then basically make sure that your route intent is nominally deconflicted from someone else's route intent. And then over time, we are looking for that to evolve into like, how do you share live information right over cell networks and over transponders between drones and other aircraft. Today, that is thought of by regulators as a separate thing from air traffic control. So air
Right.
traffic control is
Yeah.
really all about, controlled airspace, and this
Yeah.
is all about essentially under that controlled airspace near the ground. Like how do you keep these autonomous aircraft separated? But we spent a lot of time talking with our friends in the autonomous air mobility space and in the regulatory space, because these all need to converge into a system that's going to work. And where we've done this at scale in other countries, what we've done is we've taken that same UTM sort of information sharing platform and built a UI for the air traffic controllers there to have a very sort of big picture understanding of the airspace. Their general assumption is that we're following all the rules and we're staying deconflicted from them, but they can still keep an eye on us if they want to. And so they have our screens in their air traffic control operations in those countries. Exactly how that all matures, we'll have to see. I think there's obviously these UTM system is a fairly autonomous system from a deconfliction point of view,
Yeah.
but then how do you create the visibility that all the humans overseeing this need to have
Sure.
that scales? Is sort of a UI, UX, and human factors challenge.
Right now, this UTM system, does it
Mhm.
is it all random routes? Like, do your drones fly from point A to point B, or do they follow any sort of route structure, airways you
Great
guys are
question.
developing? Or
Yeah, today there's no route structure
Mhm.
that is common between operators. Internal to Zipline, we have a route structure. That's how we efficiently use the airspace. And
You've developed your own.
yeah,
With
and we've
Zipline.
needed to, because just
Yeah.
for efficiency, like I think at the low altitude airspace, a lot of people like to think of it as just empty, but it's not. There's a lot of keep outs and things like that we have to respect. That'll kind of concentrate our air traffic in through corridors and things. And so if you don't have some sort of architecture for that, you'll end up with just a clogged, can't get through kind of situation.
Yeah.
And so, yeah, I do expect that in a 5-10 year type horizon, this low altitude airspace will need that, and for everybody who'll be sharing.
Especially when you
this airspace.
start putting humans in these things too.
Yeah,
It's gotta be structured.
It's got to be structured. It's got to be layers in that structure for ensuring deconfliction, despite any part of that being flaky, in order to have that overall robustness.
So for Zipline, you guys are flying. I know the deliveries are coming in at like 100 meters, but what altitudes are you guys flying? Like, tell me about the en route.
Sure, en route, generally between 200 and 400 feet off the ground.
Oh, okay.
Yeah, so
So pretty low.
it's pretty low. Yeah.
Yeah.
And in some countries we fly higher, and that's really just a regulatory thing.
Yeah.
Here in the U.S., the FAA really wants us to stay kind of below, have cushion to this 500-foot
Yeah.
sort of
And
boundary.
do the drones follow an AGL? Do they follow terrain sort of thing?
They do. They
Yeah.
do. Yeah. And so, which gets quite interesting when you're in really hilly areas,
Sure. Yeah.
because you're just like it's
climbing.
it gets pretty wild. Yeah, we spent a lot of time on the planning systems to find efficient routes that still hug the
Oh,
ground
okay.
over mountains.
Yeah.
Because you can definitely get yourself in trouble if you try to hug the terrain, and the terrain obviously could be steeper than you can climb, for example, and you
Right.
get stuck. So
Go to vertical mode. Switch to vertical mode.
Exactly.
What are the sort of your limitations on the altitude?
we design for very high altitude. A lot of our customers around the world are flying at up to like 8,000-10,000 feet type altitude. So that's the kind of altitude we focus on at this point. But the nice thing about this is generally there aren't hard limits, right? And when we go to extreme altitudes in the future, we'll have different props you'll use at those altitudes and things like that. But because we unlike a typical passenger aircraft, I mean to transit in one flight from like 0 to 10,000 feet, generally if we're operating 10,000 feet, that'll be the
Yeah.
operation, so we can outfit those aircraft with the appropriate.
Back to the FAA with like the regulatory stuff. You mentioned you were telling me we were doing the demo when they first walked in your facility and in the Bay Area. Like, tell me about like what was when the FAA, because they've got to be like, this has got to be like foreign to them.
Yeah.
I know the FAA really well. I deal with them. I'm the director of operations for my aviation business, so I work with the FAA a lot, and it's a pretty old school mindset.
Yeah.
And this is not what we're talking about here.
That first visit was when they presented what they were thinking about for a standard for test an aircraft like these to fly over people. And we immediately came into the second day of that little workshop they were doing with us. And we came in and we're like, hey, we're just going to show you everything we've learned. And we didn't say directly, hey, your standard is way too low, but it was really clear from that conversation. It was really clear that standard was too low, and
they didn't even know what to look for, probably.
Exactly. And that's where for us it's really just been about sharing. And so the FAA has sent delegations out to Rwanda, which is our very highest volume site. They have sites there that operate our fixed wing platform at like 500 flights plus a day out of that site. And each of those flights is multi-hours. It's a massive operation there, run by a lean crew, incredibly elite. They've sent contingencies out there to just experience it, see it in the flesh, and understand what it looks like.
I just saw the Mark Rober version of it. It was rad.
Yeah.
Like I was just like the way the launch and retrieval and like so cool.
Yeah.
And so they went out there, and what did they?
Many contingencies have been out there from the FAA now to see it. And I think really what it's been for us is like, again, we want them to get as much firsthand experience of this as possible.
Yeah.
Because when you try to imagine what autonomous flight is like, just like we were when we started the company, your imagination is wrong. Like you gotta really kind of immerse yourself in it to kind of ground yourself in what it really is.
Yeah.
And it's always fun when I'm in FAA meetings now, if someone has been to one of those sites, the kind of conversation we have is just night and day if they haven't been.
Okay.
In terms of
interesting.
In terms of how grounded and practical the things will be, and so it's really that's just been our attitude, is like pull them in, give them as much exposure to what we've learned, so that they can have learned the same.
You're teaching,
things.
you're educating them.
Exactly.
They're learning. They're learning.
Yeah, I mean, you can think of it that way, but this is coming from them. They want to learn, right?
Yeah.
And so we're the largest scale operator, so it's like, hey, we'll let you in, let you see, so you can learn as much as you can. When we're sitting around debating like how to validate a detect and avoid system, we want that to be grounded in like the practicalities of the real world.
When you guys are operating, your commercial operations in Dallas, are you guys operating under Part 135?
Yeah.
What's the?
Yep, Part 135.
Yeah.
It's a bit surreal to say that.
How do you get the manuals on board those airplanes?
Yeah, that's an example of.
Is that you know what I'm talking about?
I know exactly what you're talking about. And this also just comes back to the grounding in reality. I still remember, and maybe it was 5 years ago now. So our long range fixed wing platform, the batteries are swapped by the operator every flight. And to be clear, that is a easy thing to do. It's easy to swap up the battery on your drill. Right? You cannot physically screw it up. We've tried to see if any operator can do it wrong. You can't do it wrong. The system will detect it. And the first time we met with the FAA, they were like, oh, that's a maintenance action, swapping a battery. Like, holy, no, we can't do that every flight. There's no way. And of course, but once they finally went out and experienced it, right, in their head, they're like, oh, this is, in their mind, swapping a battery was like way up here, refueling an aircraft down here. And then they came back from using our system. They're like, "Oh, this is nothing. This is
refueling."
It's just not a non-issue, right?
Yeah.
And again, it's just like getting them hands-on, getting them to see it, and then it's a lot of these in the weeds conversations of like, all right, what's the intent behind having the manual on every aircraft? What should that mean for a Zipline? How do we address that intent? Because the FAA, these regulations are built in experience, right? This is not. It's not like someone just made it up to be difficult. It's there for a good reason. And then the challenge is, how do you translate that original reason into something that applies to what we do?
Yeah.
And so we have a lot of those kind of conversations about like what that looks like and how to make that work.
Because I mean, if you look at the 135 regs, they're like, okay, It's a 130 paperwork you have to have on board. You got a registration, airworthiness. You got to have the general operations manual. If you want to use an MEL, you got to have that. If you want the AFM's got to be on board. Checklist.
Oh yes.
All of that stuff's in the regs for 135.
Sure. This is Zipline's life. It's like and this has been true for everywhere we've gone around the world. Even our first country, Rwanda, they pulled the FAA into the conversation. The FAA has this thing called Safe Skies Africa, which is where it was created in the 80s, back when there were some unfortunate tragedy disasters in commercial aviation, to like help harmonize the maintenance standards and things like that across all these countries. And so anyway, their regulatory team pulled in the FAA, their team, and it was similar conversations. It's all by exception. It's like, all right. And of course, a regulator doesn't like making exceptions. And so you have to go line by line, a lot of conversations. Yeah.
Like I said, you guys are pioneering, and you're kind of like the things that the FAA is learning and, the industry is learning. And I've learned a lot just in this conversation now. Like this is going to be, it's so useful in the future, not only for what you guys are doing in the delivery side of things, but the human side and even like, like emergency rescues. Like I was watching your thing. I'm like, God, if somebody was like trapped in the wilderness, like search and rescue, if you had a big version of that, could throw somebody in and get them out of there to a hospital. I had a friend of mine this is back a long time ago in the 80s, but he was bit by a great white shark. And it was up around Point Conception. He was surfing at Halama Beach. Sorry, he was diving. He wasn't surfing. He was diving with his brother. And he got bit. The whole thing, he was in the shark's mouth. He has bite marks across his chest and his back. Like but it only bit once, and he was severely injured. But luckily, there was a Coast Guard helicopter nearby, and they had radios, and they got him in the helicopter. But that's, if you could, hey, I have an emergency, I'm in the middle of nowhere, and have something like that come and pick you up, that saves lives. I was talking to a friend of mine. I love talking about the future of aviation, the technology, and I really believe that, like in the long range commercial, and Airbus is already testing this kind of stuff, but having autonomy built into an aircraft, but still have a pilot there, just to be there, right? Because if the airplane, if you program to do everything right, the airplane's going to be more precise. It's going to do things better. But if something gets hacked, and you have somebody there that can just like turn everything off and take care of it. I don't know, but I mean, you guys have, you're doing this now, right? And these systems have got to be ultra secure.
Yeah, it's just so important. I also like the scenario you described there. I think this is also the when I picture, the flying car of the future that people just use, right? Like that's, I believe a solid decade after, the type of situation you're describing, where it's like, okay, we think we have a flying car from an autonomy capability. We also have a pilot, and like we're using this to really get that confidence. And then, the way I think about that, then you end up with a sort of a divergence and that 10-year mark where the flying car can do the easy things, right? And then the pilots are still doing the really weird things, basically, the things that aren't the commute.
Or they're just flying for fun.
Too, of course.
If you want to fly for fun, go fly aerobatics. Like Ben, he's a big aerobatic pilot.
For sure.
Freaks me out. Cyrus almost killed himself doing aerobatics, so I'm sure he's told you that story. I wanted to talk a little bit about the environmental. We're in California. We love the environment, and what you guys are like. I did some. It's kind of hard to find data out there on the internet, but the number that I kept coming up for me was about 30% in urban areas. Call it San Francisco, LA, New York. About 30% of vehicles on the road are some sort of last mile delivery.
Yeah.
Whether it's a DoorDash, a Grubhub, Uber Eats, about 30%.
Yeah.
That shocked me.
Yeah, the world's changing around us, and in some cases you don't even notice it, right?
Yeah.
Yeah.
30%.
Yeah. This is really exciting because the fact that that's the traffic and stuff like that, that's, just silly. What's even sillier is that you have this, many 1,000-pound vehicle chauffeuring your burrito to your house.
It's insane.
Yeah. And it makes environmentally, it's just goofy. Even if that vehicle's electric, it doesn't make any sense.
No.
And yeah, for a fraction of the environmental impact, we can deliver to you with adding no traffic to the roads. And that's there's not we've looked at this in a lot of detail. And the thought experiment's interesting. If there's basically two aspects of environmental impact when you try to analyze this system like this.
Mhm.
There's the energy you use, which is a small amount. For if you're a geek, about a kilowatt hour of electricity, right, to do a delivery. And to be clear, like to do a similar delivery electric car, many kilowatts of electricity.
Sure.
But that's not actually where most of the environmental impact comes from of an electric car.
Mhm.
It comes from building the electric car.
Yeah.
And a good sort of way of looking at that is our battery pack is, these are hand wavy numbers. Our battery pack is about 1/100th the size of an electric car, right? So the environmental impact of us building that battery pack is 1/100th of the electric car's battery pack. So that's a nice big X factor. There's not a lot of things you can do in life that reduce environmental impact by 99% if you look at just that contribution.
Yeah, just the volume.
Exactly. And so the general materials, if you look across the whole aircraft, very similar. It's just a much, much smaller amount of materials. And so sort of out of the gate, you have a much lower environmental impact.
Yeah.
What's also really exciting is we can make these aircraft last a very long time.
Mhm.
We have our first aircraft in commercial operations, our fixed wing aircraft that have crossed 1 million miles. I keep comparing it to cars, and there's just 1 million mile car. Like, good luck,
Yeah.
I think
Right.
there's like one in the record books or somewhere out of the billions of cars we built, right?
Yeah.
And so you take that the environmental impact of building these aircraft, spread them out over that much. It's just a phenomenally, the replacement value is how we think about it, of saying, hey, displace that 1,000-pound car, deliver something this way. It's just hugely valuable. So yeah, we don't talk about the environmental impact of what we do. We spend a lot of time focused on the health impact of what we do, and which I'm passionate about both of them. But it's exciting.
You've solved so many problems by solving one problem.
Yeah.
And I just like the packaging alone. I took a picture. I was at my house the other day. I'm going to show it on the podcast, but we got all these deliveries and they piled up delivery after delivery. And I walked in my house, there's a pile of boxes.
Yeah.
I'm like, okay. So I started opening them up, and it's like something this big in a box this big with packaging all around it. And then I'm like, okay, I'll break it all down. And next thing you know, my recycling bin is completely packed full of
It's crazy
waste.
Yeah.
This is one day
in
my house.
Yeah. And that thing you described of like actually pile up the stuff you got versus the boxes you got them in. And it's startling how much material it took to get in there. And and we literally don't even need to use a bag. We can just deliver the product as is, put it on your table in your backyard.
You said you can deliver a dozen eggs without even being in a carton.
We delivered a dozen eggs without being in a carton. Actually, it was 2 dozen eggs without being delivered in a carton. Not a single one cracked. The eggs will probably keep in a carton because when you deliver them, they do kind of pour out. But
it's funny. It's funnier that way, though.
It is funnier that way. It was hilarious to try. Someone was like, "We got to try this," and of course, at Zipline, when someone's got to try something, we try it because we want to see what the thing can do.
I think it is a very significant thing that should be discussed. And I mean, there's no fossil fuels. There's a little bit of electricity. You eliminate packaging. The road congestion. It's just thing after thing after thing after thing.
It's huge.
They're quiet.
Yeah.
Cars are loud. This thing's quiet. I could barely hear it. When it delivers in, it put it right there. The speed, and the other thing too, when you talk about is something better, and can I get it faster? Can I get it more efficient? Humans are impatient. We want stuff right now. If I want my new iPhone, I want it right now.
Yeah.
And if I don't have to go to the iPhone store to get it, I can just zipline it, and I can have it here in minutes.
Being quiet is something we spend a lot of time thinking about, and we were recently reaching out to our communities that we serve in Dallas, and there was one person who was what we call them power users. So they were ordering from us. They had ordered 20 times in a month or two, and so we knocked on the neighbor's door and we're like, "Hey, what do you think of your neighbor getting so many drone deliveries?" And they're like, "What drone deliveries?"
Really?
And that was the perfect answer, because that's what we think you need in the future of autonomous flight for this, just for it to be okay and be something that we actually want in our life.
I was going to ask about kind of what your future vision is, but I don't know if you really want to get into that or not.
We can talk a little bit about it. It's a vague answer, which is an honest answer.
Sure.
The way we figured out this platform you saw was, we talked to our customers and they were asking for a bunch of things. Actually, fourth on the list from our customers was delivery in urban areas. Top of the list was reverse logistics, blood samples from remote clinics back to hospitals, and it was
for like rapid testing.
Exactly, which we can now do with this platform over shorter distances. And we ended up doing this for a lot of reasons that we didn't know until we went deep. And this is one of my life lessons on Zipline is figuring out how to make a product that works for your customers and for the business, especially with this kind of technology, way harder than, which is ridiculously hard. And, and it took us years to figure out the first product, the fixed wing long range platform. And it also took us years to figure out this precision delivery platform, what it should be and the details of it and all those things, and that we should do it, right? That we should bet the company on it. I expect to, we're starting that journey of going deep on what the next thing is going to be, but we're not ready to be like, oh yeah, it's this. That'll take us some more time before we're going to have enough conviction to make a next big bet.
I'm Keenan. I am a massive fan of Zipline. Have been since the first time I saw it on Mark Rober. I think you guys are you're like I said, you're pioneering something that I think is just really, really cool. And as an aviator, an aviation nerd, I know you're a robotics nerd, but like combining those two is just the coolest thing on the planet. And then to see it in action, I'm just like so grateful to be here today. And
I'm so glad we made this happen out at our test site here, because it's just fun to see like where that robotics and aviation meet, and like with code written yesterday here, before it's validated and ready for the real world, getting to see it live like that.
Thank you for coming on Flight Club Podcast. I really appreciate it.
Absolutely. It's a pleasure.
Thanks for watching this episode of the Flight Club Podcast. Please subscribe to the show, leave a comment below, and follow us on Instagram at Flight Club Pod. We'll see you next time.
This is a Kilo Bravo Media production.